we have a really interesting lecture after this one. We're going to talk about how eBay, the big eBay, how it's getting into the LLM new era. And for this, I want to call to Oded Zinman from eBay.
So I'm Oded. I'm an applied researcher in eBay for the last 3 years. I will talk about inspirational recommendations on eBay. How can we identify the core interests and passions of our users, and how can we use this information to show them to things they didn't discover before? Before I start, some details about eBay. So we have an enormous inventory of 2 billion items. We have more than 130 million active users coming from 190 different sites and marketplaces in the world. Also, a few words about our research in Israel. We have a very vibrant research environment here. We publish in top-tier conferences, some through collaboration with academia. This is just a sample of the papers that we published in the last 2 years. Also, we have a very big data to play with, coming from different modalities, mainly text, image, and now also video. Yes, so item recommendations in eBay. It comes in different contexts. For example, if the user is already engaging with a specific item, we would like to recommend similar alternatives to help them converge to what they're looking for. While homepage is our display window, where we can show cool things that we have in our inventory, as well as inspire our users. And we're also working on some new experiences for product discovery, helping users find new ideas for shopping. So you better understand the challenges that we're facing when designing recommendation systems in eBay. A few things worth noting. Our items are short-living, so data about user interaction with them is sparse. Our inventory is super diverse. In fact, it encompasses all types of products, including great amount of unique and second-hand items, which leads me to my third point, which is that our structured data and product taxonomy is limited. We have a very long and thick tail of unique items which are not attributed to a serial number or a product type. So what are we actually aiming to solve here? We want to suggest to the user fun recommendations, but still staying close to their interest. Based on their past activity in eBay, we want to suggest them to products they didn't think of. We aim to identify the passion underlying our users' shopping. For example, you can see on the left, this homepage recommendation module. We identify that this user is a Star Wars fan, so we recommend them a variety of Star Wars-related products. And also the Gen AI-generated title welcomes them with "Because You're One with the Force." A short overview of how our recommendation system looks like. It's composed of a few components. So first, a new user activity in eBay triggers our interest identification module. I will mainly focus on this part, but let's say for now that this user is looking for things related to playing basketball. Now we have this enormous pile of 2 billion items that we need to somehow narrow down, and in the first step we're narrowing it to a few hundreds, and we do that with recall source algorithms, which are relatively lightweight methods to narrow down, to get candidate items. For example, we can take the interest in the embedding space and get similar items in the embedding space. Now that we have only a few hundreds of items, we can use more sophisticated algorithms for ranking and also diversification of the results to get our final set of 10 items. As I said, I will mainly focus here on the interest identification part. So what are these interests, actually? We're interested in long-standing user passions, not one-time necessity. Like in contrast, you can think of one-time necessity-based shopping missions, like somebody looking for a refrigerator. So it includes things like cultural icons, cultural figures, hobbies, collectibles, brands, and styles. As you all very well know, so some overwhelming developments happened in the last few years, taking us to places we didn't expect at first. Only a few weeks after the release of ChatGPT, we came out with our first version that didn't enjoy the fruits of the new capabilities. In the meanwhile, open source LLMs became more and more capable, which led us to our version 2 that already utilizes open source LLMs. And also, I will talk briefly about our new version 3, which heavily utilizes LLMs and reflects our growing confidence in their output. So first, version 1. I'll demonstrate on our fictional user Bob, and let's see what he looked at, what he did in eBay. So he looked at this cool Star Wars watch, and then he looked for another wristwatch, this time the creepy-looking Terminator watch, the Arnold Schwarzenegger movie. Then he looked at this Van Gogh-style Pokemon card. At last, he looked again at Star Wars poster. So obviously, he likes Star Wars and sci-fi and action movies, and he's into movie collectible stuff, and specifically, he looked for a wristwatch related to one of his favorite movies. So in version 1, we actually decompose Bob to the items that he interacted with. We extract interests from each item separately and only then aggregate to the user level. How we do that? So if we consider again the Star Wars watch, we use things called eBay aspect, which are key value pairs of details about the item. And the core of our work in version 1 was to discern between dry details, such as the case color or case size, from passion-related details, like the theme is Star Wars. We did some we used behavioral data as well of quite a lot of Sisyphean work for manually curating the interests. And in this case, we just chose for this item Star Wars and casual style. Let's go back to our Bob. And we see that the interest that we extracted in this version 1 was very partial. For example, for the Terminator watch, we didn't extract anything. And for the Star Wars poster, we only extracted movies, which is too general. And also, we didn't identify that it's related to Star Wars, so the algorithm doesn't have any indication that he revisited Star Wars in his journey. Then we aggregate to the user level using another interest ranking algorithm. For example, it uses features like the number of items in which the interest appeared. And in this case, it didn't appear that any of them returned in more than one items. And we decided that we don't have enough confidence to infer Bob's interest. Nonetheless, we did test it in production, and it did improve homepage clicks, but we can obviously do better. The main weakness of this version 1 is in the extraction of interest from the items, as I showed you, mainly because of details that are just missing and not filled by the sellers, and also some of the types of interests are just not present, like hobbies. It's hard to find in these aspects. So we wanted to go beyond eBay's aspects, and LLMs helped us doing so. We used a teacher-student paradigm. Ideally, we would just use GPT-4 to generate everything, right? But that's too expensive, so we're using GPT-4 to generate our training data, and then we're training a smaller model to imitate it. So how it goes. GPT-4 gets as an input the item title and category, and it is guided to fill a JSON with predefined interest types, for example, brand or collectible genre. For example, here we extracted sci-fi collectibles and Star Wars collectibles. Then we trained a multi-label classifier. Again, it gets the item title and category, but then it's asked to decide whether each class or interest in this case, if it is relevant to the item or not. We trained a number of models, among them BERT with a multi-label classification head, or open source LLMs, for example, Llama 2, that was trained to generate the interests separated by commas. So let's return to our Bob. So using Llama 2, we can see that the interests generated are much richer and complete. And we also identified that Star Wars collectibles appear in 2 different items and sci-fi collectibles appears in 3 different items. And these 2 were selected for Bob's interest. For evaluation, we yet again used GPT-4. We asked it to evaluate the quality of the interest extracted from items based on a few criteria. First one is relevancy of the interest to the item. Second is how passion related it is rather than a dry detail about the item. How clear, the clarity of the interest, making sure that it's not ambiguous. And how specific it is. For example, Star Wars is more specific than a science fiction genre. So if we consider again our Star Wars watch, so for example, the interest like silver case, it is relevant, but it's obviously not a passion, it's a dry detail. And Star Trek is just not relevant, right? That's the wrong movie. So let's go over our results. For brevity, the GPT-4 evaluations were weighted, we used average score of them as indicated by the y-axis, and x-axis shows the number of interests extracted per item. So we can see that using version 1, we had an okay quality of 88, but we merely extracted 0.4 interests per item. Meanwhile, BERT extracted much more interest, but it has a bit inferior quality. And Llama 2 with 7 billion parameters had the best quality, and mainly it extracted much more interest, 2.2 versus 0.4 in version 1. A few words about future work, or more correctly, current work that we're working on right now. We wanted to better understand our users and the relation between their interests. In the meanwhile, we got more GPUs and more advanced GPUs, and also more quota for calling external LLMs. Even more importantly, growing trust in LLMs in the organization enabled us to go for more novel approaches. This time, we're not bounding ourselves to a fixed list of interests. And also, we represent the user interest as a tree, as you'll see soon. Again, we use this teacher-student paradigm that GPT-4 teaches, and this time Mistral 7 billion parameters is imitating. But here, the LLM gets the user as a whole. It gets all his interests in the prompt, all its items in the prompt, and it is guided to generate this interest tree encoded as an S expression. So let's look at how it looks in our Bob. So the top nodes are the broad passions like sci-fi movies. As we go down, we get to more specific interests like sci-fi watches, and the leaves are actually items that the user interacted with. This approach shows very promising results, but it also introduces some new challenges. Among them, the ML engineering challenge of generating longer output, but still maintaining the needed throughput. And also the algorithmic challenge of how to incorporate long user history into the prompt. We're currently working on these challenges. Thanks.
Great work. My question is, do you use the images themselves? It looks like you only use the text features. Did you try like VLM, multimodality stuff?
No, yeah, that's for our future work. You're correct, we can use it.
Thank you. Have you evaluated the LLM labels?
The labels themselves?
Because I guess there is a bias between items for a known a subject and the long tail of items that I guess the LLM know less about them.
When you ask about labels, you mean the interests that GPT-4 generated?
Yeah, for the training.
For the training, yeah. So we actually, before we use them, I didn't go through all the process, but we also had some more LLMs like guided to check that the interests are of good quality, as you saw also by the evaluation, and also that they are safe to work and not, don't include any nudity or whatever, what kind of, so we had some extra checks about it. We're bounded. We need GPT-4 to evaluate GPT-4. That's that's the best we can do actually. If we want to work with a magnitude of interest, like we have thousands and thousands of interest, it's not manageable.
Last question, please. Yeah.
Hi, great presentation. Thank you. I have a question. Did you check the legality of using the...
Excuse me?
Did you check the legality of using GPT models for generating training data? I'm pretty sure it's in their end user license agreement that you cannot be using that for such purposes.
Sorry, I didn't get you.
Did you check the legality of using
the what? This word? Yeah?
Legality.
Legality.
Of using GPT models for using them in such mode for generating training data. I think in their end user license agreement they prohibit this usage.
No, I don't think. From what I know, it's not allowed to use it to train another language model, but to generate training data, from my knowledge, it's legal. Legal didn't stop us at any point. But it's not allowed to
did it go through the legal process inside eBay?
Yeah, we did. It's it's not legal to try to compete with GPT-4, but other than that, that's what you do with GPT-4 actually.
Okay, cool. Thank you.
Thank you, everybody in the audience, and thank you, Oded.